gas law we will be demonstrating is Henry's law, which states as temperature increases, the solubility of the gas will decrease. For this demonstration, you will need a Bunsen burner, soda, a container to capture the overflow, crucible tongs, a nut, and a striker. Our first step is we're going to light the Bunsen burner. Now, we will place the nut into the flame. We will now transition the nut into the soda. As you can see, according to Henry's law, the temperature inside the soda increased, and therefore the solubility of the gas decreased. So all the gas escaped at once, bringing the liquid outside and into the container. And that's Henry's law.
This is the second gas law, Charles' law. It states that temperature is proportional to pressure, so as one goes up, so does the other. What you'll need to do this experiment is a hot plate, a beaker full of water, and a broken down ping pong ball is crushed. First, bring the water to a boil. Next, take the ping pong ball and put it in the water, and then use the stirring rod to stir it around, make sure it gets in there. After a while, you should notice that the indents are going away bit by bit. As you can see, the indents are gone. This is because as the temperature increased, so did the pressure inside of the ping pong ball. All this outward pressure pushed the indents out, keeping the volume the same, but exhibiting more pressure throughout the experiment.
The third law is Boyle's law. It states that pressure is proportional to volume. What we need here is a 2-liter filled with water and a medicine dropper filled with food dye. It doesn't specify what color, we just decided to use red. What we'll do is we will take this dropper and put it into the 2-liter. Screw on the cap. Even though it's not matching, don't pay attention. As you can see, as I squeeze the container, it decreases the volume of the container, which increases the pressure on the medicine dropper. We put the red food dye into the medicine dropper to trap the air inside of the medicine dropper.
The fourth gas law is Gay-Lussac's law, which states that temperature is directly proportional to volume in an ideal gas. Kelsey will tell you what we need for the demonstration.
What you need for the demonstration is a Coke can, well, it's any type of can really, an aluminum can filled with about 5 milliliters of water, a beaker with ice water, and a hot plate, as well as crucible tongs. And Connor will do the experiment.
First, place the aluminum can on the hot plate. Once you see steam, quickly take the aluminum can carefully in the crucible tongs, in the beaker tongs, and flip it quickly into the ice water.
Gay-Lussac's law states, as the temperature quickly decreased when we put it in the cold water, the constant volume of the can, because it became cold, the pressure became less, and the atmospheric pressure around it became too great for the inside of the can, thus it imploded. And that's Gay-Lussac's law.
Smells bad over here. I don't like this hot plate.
Hello, today we will be learning about Henry's law, and what it states is as temperature increases, the solubility of the gas decreases. Hi, today we will be demonstrating Henry's law. Henry's law is as the temperature increases, the solubility of the
We will now transition the bolt into the soda. Oh my god!
Try to lay it sideways.
Okay, did you stop it?
This is the second gas law, Charles' law, in which pressure, as it increases, will equal temperature as it increases. That's terrible. This is the second gas law. It says, this is Charles, no, not good. This is the second gas law, Charles' law. It states that since pressure and temperature